Hi class, we're going to be going over chapter 2 in the Runestone book. It covers variables and expressions and statements. But before we do that, let's talk about this word object. Actually, in Python, everything is an object. 2 is an object. 3.14, this is an object. The word hello, that's an object. Now, I might use the word values as a kind of synonym. Either way, objects, values, think about them the same way. Again, everything in an object is everything in Python is an object, and objects are stored in memory. So I might have this memory chunk, a bunch of bytes, and it might have the word, hello in it. That would be an object, a bunch of contiguous bytes in memory. Now, I typically won't diagram an object like this, but I will diagram an object like this. I'll just use a bubble, a circle, and I'll put the contents of that object inside of that bubble. Okay? So maybe, this is the object 2. This is the object 3.14. Okay? Now, every object in Python has a class name or a data type. And I'm going to use this word data type a lot in this class. The data type of the object 4 is an integer. The data type of this word that you see right here is what's called a string. The data type of this number here is called a floating point. It has a decimal point there. Okay. Now, Python, you can actually find out the type of object that it is using the type function. So what I could do is I could give the type function an input, and then I could say print that the data type out. So the type of 17 is a class int. The type of this is a string. You notice the difference between these two is merely these quotes on either end. So having these quotes here make it a string, but if I don't have it, it's called an integer. Now let's talk about strings a little bit. What is a string? A string is like a word, but it's more than a word. It's a sequence of characters. And that sequence might not even have any characters in it at all. In fact, we have this, what's called the empty string. That is made up of 0 characters. Now in Python, there's multiple ways of indicating a string. There are 4 ways. Now, why are there 4 different ways? Some languages only have 1 way. But Python gives us 4 different ways. I could put single quotes on either side. I could put double quotes on either side. And so whatever is inside these double quotes, those are all the different characters inside of this string. But suppose I want my string to actually be something like this. He said, double quote, hi. I want the double quote here and this double quote here, these characters, these key presses on the keyboard, I want those characters to be part of the string, just like I want H to be part of the string. So if I were to put double quotes around here like that, that would be very confusing. Where does it end? And so we don't do that. So instead, we use this idea of putting single quotes around it instead. That way it's very clear. We know then that all this stuff in blue, which is inside the single quotes, are part of my actual string. And we could also, if I want to do something like this, Mark's '(s) laptop. In this case here, I have this single quote. I want that character to be part of my string. So it'd be very confusing if I use single quotes here. is this the start and is this the end of my string? No, I want this single quote to be part of the string, and I don't want it to indicate the end of the string. So what I will do is I will use double quotes. And so this single quote now is interpreted to be part of my string. So then why do I have triple quotes, triple single quotes, or why do I have triple double quotes? Well, these are useful in this example here where maybe I want to put double quotes and single quotes inside of my string itself. Therefore, these triple quotes are a way to mark the beginning and the end of my string. Now, there's another usefulness to it. It's also useful when I want to do kind of a multiple line strings. So maybe hi, hello. So when I hit the return character right here, it's actually interpreted as part of the string. So I could have a multi-line string using these triple quotes. Okay. Now, Python just stores the characters inside the object itself. So for example, if I made this object, he said hi, these words right, or these letters right here are the string indicated by this right here. I don't include these single quotes around it inside the object itself. Okay, let's talk about functions a little bit. We talked last time that we could use, a very similar kind of notation, this f of x notation, to indicate a function in Python. And in math, we have our input, and we also know that our function in math will have some sort of output number. Now, in Python, there's a lot of similarities, but here are some differences. I could have multiple inputs in Python. So if I do that, if I have multiple inputs, I put commas between the different inputs. Now, we can actually do that in math, but I know a lot of you have not hit that kind of math yet that uses that kind of syntax. Now, in Python, we can also have functions that have 0 inputs. So in that case, I don't put anything in here at all, just parentheses. Now, with any function, I need to know precisely the needs of that function. Maybe it requires a string for the first input, an integer for the next input, and a floating point for the third input. I must give it exactly those inputs in those exact order. So with any function, you always have to understand what are the requirements, if there are any requirements. Some functions, like the print function, are very flexible, but some functions are very specific. And we'll see some of those. So functions may return an answer, just like in this math function up here. F of x always give an answer, but in Python, functions may or may not return an answer. It may or may not output an answer. So I'll put this word output here. Here's an example of a function called the input function. And what it will do is it'll print this string out to the console, and then it'll wait for us to type something in, and when we hit the return, whatever we typed in will become a string that gets returned to this variable here. And so I like to show a value getting returned by this little arrow here, saying that, oh, this input returned a value, and in this case, the input function always returns a string. So let's take an example of a function. Just make this up. The Fibonacci function has one input, and let's say this is a made-up situation. Let's say that this input x has to be an integer. If that were the case, if I did something like this and I supplied this floating point value to it, that would be illegal. Or if I gave the string 5 to it, that would also be illegal. Okay, so I need to really take care of asking myself, for this particular function, what should the input be? Let me make sure that it is of the proper data type. If it's not the proper data type, there are some conversion functions that can help us convert from one data type to another. We have the int function, and what that does is it takes an input, say this floating point number, and it converts it into an integer. And the way it does that is by truncation. It doesn't round, so not rounding. You see another example here, negative 1.92. It just truncates the 9 and the 2 away. We can also convert strings, so I could do something like this. The integer of this string 5 returns the value 5. Now, if I said something like the integer of the word hello, there is no integer of hello. This is actually illegal. We get an error. We'll talk more about these errors later on, but it cannot turn any string into a number, only if it is an integer inside of the string. Okay, we also have functions called the float function that will turn a string into a floating point. So I could do something like float 1.23, and that returns the value 1.23 as a floating point value. I could also turn things into a string, turn numbers into a string. So if I had string of 12, the output of this function is this string that has the characters 1 and 2 in it. Okay? Now let's talk about variables. What are variables? Variables are names. They're names that reference an object. The analogy that I like to use is suppose we have a lot of people. We need names for the people. So instead of just saying, oh, that person here or that person there, we give names. So we might have Joe being one person, and we might have Bob being another person. In the same way, we have names for objects as well. So as a way of referencing different objects, I have this object 2, I have this object hello. How do I reference it? I need names for them. So we can make up names for them, and the names could be any variable name we want. I could call this one X, I can call this one Y. Names are like labels, sticky notes, name tags that reference some particular object that I want to use. Objects could have multiple variables, variable names referencing it. So maybe I might want to call this one X or Z. Just like Bob up here, maybe Robert is another name that references that person. So multiple variables can reference the same object. What I don't want to have, this is where you don't want to do it. You don't want to have two variable names of the same name referencing two different objects. That would be very confusing. If I say print X, what would you print out? Do you print out 2? Do you print out hello? You don't know. So we don't allow replication of the same variable name within the same part of the program. Otherwise it'll be confusing. Now how do we define a variable? How do we point it to an object? This is the syntax. We say the object on the right hand side, we have the variable name on the left hand side, and we say equals. So variable name equals the object. Give the name score to this object 95.3. Note that this is not like the mathematical equal sign. This line down here, that's illegal. In math, it's okay. But in programming, in the programming language, it's not saying that they're equal. What it's saying is this variable will reference this object on the right-hand side. Whatever the object is on the right-hand side, it will receive this name. This name will then be its reference for further use later on. Now, variable names can be reassigned. And we have to be careful about this. So this is the way it works. In Python, we interpret code line by line and execute them line by line. So in this case, I have 3 lines of my program. The first line will get executed. It makes the object 5. It handles the right-hand side first. And once the right-hand side is done, then it does the assignment. So then A gets referenced to this object 5. So now we finished executing line 1. Now we execute line 2. B is equal to A. So a new variable B gets created, and it then points to the same object that A points to. Now we're done with line 2. Let's execute line 3. A is equal to 6. Now what happens here is the 6 says, let's make a new object with the value 6 inside of it. Then we say A is equal to that, or A points to that, so we reassign. The linkage that has A pointing to the 5 gets removed, and now A references this new object 6 down below. Notice this is very key. Now it might, if you were to look at this from a mathematical standpoint, you might think that, oh, B and A are always the same. They are equal to each other. But that's not the way to interpret this in kind of the programming world. Note, B is not equal to A after line 3. So after we've executed this line, things have changed. The A now points to the value 6. B points to the value of 5. They are not the same. So don't think of line 2 as a always is true kind of statement. It's something that happens at one instance of time. It gets executed, and then we keep on going, and after that, after we continue on, it could very well be that A changes to something else. Okay, what are some legal variable names? In Python, we must start with either a letter, uppercase, lowercase, or an underscore. We cannot begin with a number, although numbers are okay to be had in the variable name following. So I could have something like A1, but what I can't do is 1A. That's illegal. Cannot start with a number. Now, spaces are not allowed, so you can't have something like A space B C. It is case sensitive, so that means that little a, little b, little c is different as a variable name from capital A, B, C. These are interpreted as 2 different variable names. Other illegal things, let's see, something like a $, that's illegal. Must be a character, or it must be a number, or must have an underscore in it. Those are the only things. It cannot have a $. You cannot have a caret, character like that. All of these are illegal. No periods, so you can't have a, this is not a valid variable name. Now, there are some recommended naming conventions. Even though I've just defined what's legal, there's still some things you should and shouldn't do. You should always try to make the name meaningful. What I mean by that is, You know, in algebra, you were taught, I hope, to define your variables. So in algebra, you might say something like this: let x be the number of hot dogs that I bought. But actually, that's not a very descriptive name. I might forget what x means. So instead, let's do something better. Let's name it in a descriptive way. So num hot dog. So that I could make up a variable that is made up of all these letters that makes it a lot more kind of meaningful as a name, a lot more descriptive. Now we do have another convention where we start with the lowercase, and then each successive word is then capitalized. It just makes it more readable. It's all about creating meaningful, readable variable names. Now, there are some words that you just can't use. There's a bunch of what's called reserved words that are not usable for variable names. So you don't need to memorize all these. We are going to be talking about them as we, move on from week to week. But just know that there are some words that are illegal because Python already uses that word for something else. Okay, operators. Let's talk about that. Now, an operator is something that operates on two things, like an addition operator, multiplication operator, and they are the typical ones that are familiar from math. What we have to really understand is, how do they operate? We have to think about the data types. If I have floating point on either side of my operator here, the answer will be a floating point. If I have integers on both sides, so if I have 5 plus 2, so integer plus integer, I get an integer answer. So always think about data types, because you want to know what the data type of your answer will be. Now the division sign is special. This will always be a floating point. So if I say integer 4 divided by integer 2, it will be a floating point answer. Okay, so that's a little special case. Plus, subtraction, multiplication, it works according to what I set up here. But this single slash always is floating point. Now, all of this follows the normal PEMDAS ordering. We also have a way of specifying exponentiation. So this is the way in Python of saying 2 to the 5th power. And we also have some integer divisions. If I use the slash, it's actually an integer divide. We get the quotient of 22 divided by 4. We also can get the remainder using this percent sign. And so we have, if I did 22 divided by 4, my quotient is 5, my remainder is 2. And this percent sign, if some of you have taken math, or you might have seen this in some kind of math areas. So it's also known as the modulus function. So 22 mod 4, 22 modulus 4, 22% 4, same thing. Lastly, when we are using this operator, if we mix it with strings, a string plus an integer in Python, not allowed. That's an error. A string plus a string, that is allowed. But when we do that, we're not really adding, we are concatenating the strings. So you see down here, the string 5 plus the string 7 is not the string 12, it's the string 5, 7. So this is the example here of concatenation. And here's the example of just a plain error. 4 plus string 5. You might think that Python would be able to handle this, but it says no, you can't mix them. It will give you an error. Okay, so that's it for today's lesson. Have a good day.